In section 4.1, we are going to be solving quadratic equations. And so first, we are going to look at solving by graphing. When you graph a quadratic equation, you're going to find the x-intercepts, and those are going to be your solutions. So all you have to do is graph and find where it crosses the x-axis. Sometimes there's 1, sometimes there's 2, and sometimes there may not be any. If there's not any x-intercepts, then your solution is no solution because it doesn't cross the x-axis. Um, and that's with graphing. The next method is going to be using square roots. Using square roots, we are just going to solve, and we're going to take the square root of each side. And lastly, it is factoring. So factoring we'll get into a little bit later, but we're going to write the equation in this form. So we have ax squared plus bx plus c equals 0, and we will factor from there. All right, so just some highlights there. Now, right here, 4.1, solving quadratic equations, example 1, says solve each equation, by graphing. So if we are going to solve each equation by graphing, first of all, we have x squared minus x minus 6 equals 0. Well, we can't graph like that because we can't graph an equals 0. But instead of equals 0, we can rewrite that as f of x equals x squared minus x minus 6. So instead of the 0, we now have f of x. Now you can put that in your calculator. And guys, that's pretty much all you're having to do is put that in your calculator. I would like for you to draw a table as well. Remember, on your calculator, to get to a table, you just press Control T after you have your graph in there, and that'll get your table up so you can write it down. To get rid of the table, you're going to press Control T again, and the table will go away. So once you put that in your calculator, you'll be able to graph your function, and this graph looks like this right here. And if you notice, I've already highlighted the 2 points where it crosses the x-axis. So if we look at our table, I have negative 2, 0 is where it crosses the x-axis, negative 1, negative 4, 0, negative 6, 1, negative 6, 2, negative 4, and 3, 0. So negative 2, 0, and 3, 0, those are the points I have highlighted on my graph. So I would like for you to highlight them on the graph, and I would like for you to highlight them on the table. So your answer here is going to be x equals negative 2 and x equals 3. So we have x equals negative 2 and x equals 3. Okay, so let's move to another one. Now this time we have negative 2x squared minus 2 equals 4x. Well, this one is not equal to 0. So there's a little bit of work that we have to do first. So looking at that, we have a 4x on the right side. We are going to subtract 4x from both sides first. And when we do that, subtract 4x from the right, subtract 4x from the left, we are going to get negative 2x squared minus 4x minus 2 equals 0. Now we have it equal to 0, and we can change that 0 to f of x. So we've got f of x equals negative 2x squared minus 4x minus 2. Again, put this in your calculator. Clear the previous equation that you've done, put this in your calculator, and get your table. And here is both table and graph. So our table, negative 3, negative 8, negative 2, negative 2, negative 1, 0, 0, negative 2, and 1, negative 8. Again, we're highlighting the x-intercept, which would mean the y is 0, and where it crosses the x-axis, again, the x-intercept. So this time there's only 1 point. And so our answer is x equals negative 1. Now you're going to hear several different words that all mean the same thing. You may hear or read find the solution, or find the zero, or find the x-intercept. Those are all the same. They all mean the same thing. Roots is another one. Find the roots of the problem. That's the same thing too. It all means find where it crosses the x-axis or find where the y is 0. Okay, so again, our answer here is x equals negative 1. All right, a third one. 1/2 x squared equals 6x minus 20. This one again is nothing is equal to 0. So we are going to move everything to the left. So I keep doing that. We're going to move everything to the left, so we're going to subtract 6x and add 20 to both sides. So on the right side they cancel. So we now have 1/2 x squared minus 6x plus 20 equals 0. And we can change that 0 to f of x. And so here's our graph, or our equation, excuse me, and our graph. Plug this equation into your calculator and graph it. And if you notice, this graph right here never crosses the x-axis. So when you write your table, here's your table, but there is no real solution. No real solution, because nowhere does it ever cross. Now the reason we say no real solution is because there's a type of solution we'll find later on in the year, but as far as it crossing the x-axis, it doesn't. So there is absolutely no real solution there. Okay, so that's all of our graphing. Again, just to review, we have 2 answers, we have 1 answer, or we have no answers. And I shouldn't say answers, we always have an answer, but we have 2 solutions, 1 solution, or no real solution. Okay, so let's now look at example 2. Example 2, solve each equation using square roots. So right here, I have 4x squared minus 31 equals 49. Well, this one is going to be a little bit easier because I'm not going to graph it. And yes, graphing was easy, but I'm going to add that 31 to both sides of my equation. And it's going to cancel over here. So now I have 4x squared equals, add your 49 and your 31, and that's going to give you 80. Now you're going to divide by 4 on both sides, and you get x squared equals 20. Well, now that I have x squared equals 20, I'm going to take the square root of both sides. So if I take the square root of x squared, I also have to take the square root of 20. Well, the square root and the square cancel, so I'm left with x over here. And anytime I take the square root of a number there, I have a plus and a minus. I have a positive and a negative, so I need plus or minus here. But 20 is not a perfect square. So if I look at a factor tree with 20, the smallest number that's going to go into 20 is 2. Well, that's going to be 2 times 10. Factor 10, and that's 2 times 5. So those are all my prime numbers, 2, 2, and 5. So if I look at that, then 2 times 2 is 4. 4 is a perfect square. A perfect square is a number that you can take the square root of and get a whole number, not a decimal. So if I take the square root of 20, I have to break it down into the square root of 4 times the square root of 5. So 4 times 5 is 20. 4 is a perfect square. Now I have x equals plus or minus. Go ahead and take the square root of 4, which is going to be 2. I cannot take the square root of 5, so there's my answer. Now, you cannot put a decimal as your answer on these. If you put a decimal as your answer, it's going to be totally wrong. So please make sure that you break this down and do not put a decimal as your answer. All right, let's look at another one of those. So here we have 3x squared plus 9 equals 0. Let's subtract 9 from both sides. And so we get 3x squared equals negative 9. We are going to now divide by 3 on both sides. And x squared equals negative 3. So now your next step is to take the square root. The square root of x squared equals the square root of negative 3. Your square and your square root will cancel. So you have x is equal to the square root of negative 3. Well, can you take the square root of a negative number? And no, you can't right now. Again, like I said before, we will get into that later on in the year, but as of right now, no, you cannot. So our answer here is no real solutions. No real solutions because we cannot currently take the square root of a negative number. Okay, let's look at one more. Here we have 2/5 times x plus 3 squared equals 5. A lot of you are going to try to distribute this 2/5 in, but you cannot because of that square that's there. So we're going to have to divide both sides by the 2/5. So get that out of there. We're going to divide both sides by 2/5. That cancels, and I'm left with x plus 3 squared equals, well, if I divide by 2/5, some of you were having trouble with this before. This is basically 5 over 1. So if you don't have your calculator and you're having to do this by hand, you can rewrite this as 5 over 1 now times 5 over 2, because we're going to keep the first fraction, change the division to multiplication, and flip the second fraction. So now I have x plus 3 squared equals 25 over 2. You can put it in your calculator as well. Just make sure when you put it in your calculator that you put that 2/5 in parentheses. It's going to make a big difference. So now go ahead and take the square root of x plus 3 squared and take the square root of 25 over 2. I know that x is not by itself over here, but we have a x plus 3 squared, so the next thing we have to do is get rid of that square. So those cancel, just like before. And we have x plus 3 equals, well, right here, we have the square root of 25 over 2. I can break that up and take the square root of each one individually. So I have the square root of 25 is 5, and then I can't take the square root of 2. So I just have to leave it as the square root of 2. But there's a big problem there because you cannot have the square root in the bottom of a fraction. So we have to do what we call rationalizing. When you rationalize something, you are multiplying. So right here, I'm going to have to multiply the top and the bottom by the square root of 2. And that's going to help me get the square root out of the bottom of the fraction. So we're going to rewrite the left side, x plus 3 equals, on the right side now, I have 5 times the square root of 2. And on the bottom, the square root of 2 times the square root of 2 is the square root of 4. Well, 4 is a perfect square. So now I have x plus 3 equals 5 square root of 2 over 2. Okay, so that part's done. Now I just have to get rid of this 3 on the left side. So now I'm going to subtract 3 from both sides. And you know there's one key thing that I forgot to write down, and that's that plus or minus that goes in front every time you take the square root. So don't forget that. Alright, so now subtracting 3 from both sides. Those cancel, and x equals plus or minus 5 square roots of 2 over 2 minus 3. And there is our answer. Okay, there is a little bit more to this, but as of right now, we're going to stop here and we'll pick up with the rest on another video.